Today we will study a shift register. So as we know that we have classification of the register, it's serial input, serial output, serial input, parallel output, parallel input, parallel output, parallel input, serial output. Okay, so we are studying about seesaw, serial input, serial input, serial output, serial in, serial out. As we are using a D flip-flops, okay, these are the flip-flops. So there's shift left and shift right. How it can be possible? As a shift left means we are shifting the inputs to the left side, D3, D2, D, and shifting the outputs Q3, Q2, Q1, Q0 on the, here we will get a serial output. Okay. Now if we want to store a 111 4-bit in a registers, okay, so we have to use a 4 flip-flops. Now how it will go to these registers? So if we giving this 1 bit to first here, so it will go to here D3, and initially there will be a 0 output in all these. So at D3 we are giving a 1. So now D3 is 1, and initially if Q3 is 0, so D2 is 0, Q2 is 0, Q2 is 0, then D1 is 0, and Q1 is 0, so D0 is 0. So what will be the output if there is 1? So there will be in a Q3 we will got a, as a 1 we get an same output, there will be no toggling. Here we is 1 0 0 0. So what are the outputs of the, by triggering a clock pulse? Here is 1 0 0 0. Then after that the other inputs, again we are giving a 1. So by giving a 1, there is 1. So by giving a 1, here we know that Q3 is 1, so D2 is 1. Then Q2 is 0, D1 is 0, Q1 is 0, then D0 is 0. And what are the outputs of this? 1 1 0 0 0 0. So what we are getting on this next edge clock triggering? Here we got an 1 1 0 0. Then next bit is entered by giving a clock. Again it's stored above 1. So here is 1. D2 means Q3 is 1. So D2 will also be 1. Q2 is 1. Then D1 is 1. Then Q1 is 0. Then D0. So what are the outputs of these? D3 means 1. Here also we will get a 1 1, then 0. So what are the outputs? 1 1 1 0. Then after giving, now we have to give a last bit storage, that 1. Then there is 1. D2 also will be 1. D1 will also be 1 because its Q2 is connected and Q2 is 1. So D1 is 1 and Q1 is 1, then D0 also 1. So what are the outputs? 1 1. Here again 1, then 1, then 1. So this bit is stored in this type of register, shift in serial in serial output register. Now how we can see in this a waveform? Okay, see here, this is a initially, if the D in means initially, so initially all the clock pulses is 0. Okay, after that we will see for the Q3, Q2, Q1 and Q0. Okay, so as we see here, at the first edge of triggering, this first clock pulse edge triggering, Q3 is 1 and other insides are 0. Okay, so for the first one it's a 1. Okay, then after that, for the first clock pulse, and Q2 is 0 for the first one. Sorry for that. Q3 is 1 for the first clock pulse, then it's 1. It will be a high position. And Q2 is 0 for the first clock pulse. Q1 is also 0. Then Q0 also 0. After that, for the next clock pulse, means next triggering, again Q2 is 1. Sorry, Q3 is 1. Q2 also will be 1 for the next. It's up to here. Just see here. I just forget to make it. So by here seeing that it's a 1. Up to here, Q2 for the next second. So there is second. It will be high up to here, and Q1 is 0 and Q0 is 0. Then again it's up to here, 0, 0. Then for the third, 1, 1, 1, 0 means again 1. Q2 also will be 1 and Q1 is also 1 for the third one. Then for the fourth, and Q0 is 0. Then for the fourth, again Q3 is 1. First, second, third, and then fourth again. So then Q2 is also 1. Q1 is also 1 and Q0 is also 1. So these are the waveforms for the shift in serial in serial output register. Here we stored here. What is that? Here what we can see? 0, 0, 0. Then for this up to here, 0, 0, 0. Then for the triggering, after that here 1, 0, 0. Then for the next 1, 1, 0, 0. Here's 1, 1, 0, 0, 0. Here we get it. Then for the next one, 1, 1, 1, 0, 1, 1, 1, 0. For again it's 1, 1, 1, 1. These, so they here in this register we stored this. So this is a shift register for the serial in and serial output.